Hey everyone, and welcome back. This explainer is brought to you by Forge College. So, in our last lesson, we dug into Turbine, right? And we talked all about the absolute necessity of deterministic testing. Well, today, we're crossing the bridge. We're stepping out of those cozy, safe local sandboxes and heading straight into the wild west of testnets. Let's talk about scaling your deployments without breaking a sweat.
Okay, let's dive into this. Picture this. You've written your smart contract, the compiler is perfectly happy, and honestly, you're feeling like an absolute genius. But is it actually ready for the real world? Look, deploying straight to mainnet right out of the gate is basically like testing a brand new jet engine while you're mid-flight. It's expensive, it's highly risky, and frankly, it's terrifying. What we desperately need here is a structured rehearsal space.
Here's our engineering blueprint for the explainer today. We'll map our journey from testing to deployment, meet the 4 environments, figure out choosing your arena, walk through the multi-stage lifecycle, translate that strategy to code, and finally, do a review and next steps.
Section 1. From testing to deployment. Now that massive, comprehensive test suite you just built, that gives us a factual baseline. It tells us exactly what works locally and what actually needs live network verification. So the crucial point I want you to remember is this. Environment choice is a tool, not a ritual. Right? We don't just deploy to a testnet to arbitrarily check a box on some list. We deploy to verify very specific behaviors, like functional correctness, gas profiles, or, complex Oracle integrations.
Section 2. Meet the 4 environments.
To do this verification properly, we really need to understand the matrix of the 4 primary arenas we're working with. Your local node, that's basically like rehearsing lines in your bedroom. It's designed for super fast iteration. But a public testnet like Sepolia, that's your live preview show. That is exactly where you test actual network latency, unpredictable mempool chaos, and external node reliability.
And this brings us to the mainnet fork. I like to think of a mainnet fork as freezing the real world in carbonite. It's so cool because it allows us to safely and locally test realistic gas profiles and external integrations against the exact on-chain state, all without spending a single drop of real ETH. I mean, how great is that? Finally, we have the staging network. So if the local node is your bedroom and the public testnet is the live preview show, staging is your VIP dress rehearsal. It's a private cluster, and we use it semi-realistically after we've squashed those deterministic local bugs, but right before we go out and face the absolute chaos of the general public.
Section 3. Choosing your deployment arena.
In all the programs we teach at Forge College, we really emphasize navigating these terrains using a strict compass. We don't guess, we measure against 5 key criteria: parity, determinism, speed, cost, and external integrations. Think about it. If your tests fail locally because of some weird Oracle mismatch, you don't need speed. You need parity. You absolutely need an environment with the exact real-world state to debug that properly.
It's a constant balancing act, isn't it? You're always weighing the need for lightning-fast, snappy local debug loops against the strict necessity of perfect on-chain state replication. Just fixing a typo in a require statement? Use local, for sure. But chasing down some gnarly, state-dependent bug involving simulated liquidity? Yeah, you absolutely need that heavy-duty mainnet fork. No way around it.
Section 4. The multi-stage lifecycle.
Let's see how this builds on itself. By using promotion as gating, we basically turn messy, ad hoc deployments into this really clean escalator of stakes. We go from local dev up to fork-based integration, private staging, public testnet verification, and finally, mainnet readiness. But here is the golden rule. If a criterion fails at any gate, you stop. You immediately step back down the staircase to a lower environment so you can reproduce that bug safely and, more importantly, cheaply.
Section 5. Translating strategy to code.
What's really interesting is how we translate that strategy into code. Think of your network configuration like a locked vault. To keep the bad stuff out, you need precise keys. By explicitly matching your chain ID in your configuration, you effectively prevent those dangerous replay attacks between networks. And by using environment variables for things like RPC, URLs, and deployer keys, your golden keys, you keep your secrets safely hidden out of the public repo. Seriously, never hard code them.
For our Foundry users out there, bringing a mainnet fork to life is literally like striking the anvil. By using simple fork flags in your CLI command, you can reach out and forge a highly specific, deterministic block state. This means you can pull that exact moment in time locally, reproducing a failing integration test over and over again until you hammer out the fix. It's a real game changer.
Section 6. Review and Next Steps.
All right, let's crystallize all this into a repeatable workflow for your CI pipelines. Here are your core takeaways. Environment strictly mapped to your verification goals. Use forks early and often for tricky stateful bugs. And absolutely encode your promotion gates directly into your CI. Treating environments as a mapped hierarchy rather than just an arbitrary ritual is exactly how we deploy with absolute confidence on every single release.
Now, I want to leave you with a quick challenge before our next lesson on testnets. Can you find just one failing integration test in your project right now that depends on external data? Track it down. Bring that failing test along with your network configs to the next session, and we'll dissect it and fix it together.
Thank you so much for joining me today. Remember, this explainer was brought to you by Forge College. If you want to master these skills and start building smart contracts without those midnight panic attacks, head over to forge.college to learn more about this and check out our other Web3 topics. Happy coding, and I'll catch you in the next one.